Hello mga ka-Try! Welcome to episode 8 of Try Robotics. In episode 7, we've talked about DC motors. So we've learned about the different types of DC motors, the geared DC motors and the brushed and brushless DC motors. And we also program our K-12 robot to move in different directions, move forward, backward, turn left, and turn right. And tonight, we'll talk about another types of motors used in robotics, which is the servo motor and the stepper motors. But before we do that, have you ever wondered how our K-12 robot moved in different direction? How its motors rotate clockwise and counterclockwise? We'll talk about that tonight before we discuss about our servo and stepper motors, because knowing about how it works is important in our discussion about servo motors. Now, I know you're ready, so let's begin. Now, we have here the same motor. DC motor. This is a geared DC motor commonly used in robotics, and I've attached a wheel on it, and I put a mark here so that we'd be able to see its rotation later on. And as you can see, I have here the power supply, which is at 3 volts now. It's currently not sending voltage to my motor, that's why it's still not rotating. And then the positive terminal is connected to one side of the motor and the negative terminal is connected on the other side. And so let's see how it works when I turn on the power supply. So as you can see, the motor is rotating on a clockwise direction. But what if I would like to turn the direction of this motor on a counterclockwise direction? So to do that, I will need to exchange the connection of the positive and negative terminals of the motor. So let me do that. I'll just turn it off at first. And there. So now I've interchanged the connection of the positive and negative terminal of the power supply. So the positive now is on the left side and the negative terminal is on the other side. And a while ago, the rotation of the motor is clockwise. Now let's see if it will now turn counterclockwise. Let's see. There. So as we can see, it's now turning counterclockwise. And so that's how you change the direction of the motor if you would like to move it clockwise or counterclockwise. But how come that in our K-12 robot we're able to rotate the direction of our motors in a different direction without doing that, without changing the wires? So that was made possible because of what we call the H-bridge. The H-bridge on this robot is here. So this small piece of circuit, that is the H-bridge, and as you can see, it has 4 inputs, in1, in2, in3, and in4. So those are dedicated for the 2 motors, the left and right motors. So by changing the polarity of the supply that is applied to these pins, we are changing the rotation of the motor. For example, if we would put 0 volt on the in3 and then 5 volts on the in4, the left motor will rotate in one direction. But if we interchange that, if we put here a ground and 5 volts is on the in3, it will rotate on a different direction. So that is the purpose of the H-bridge, so that we're able to exchange the connection of the power supply to our motors electronically. And this is a small part, as a small piece of H-bridge. It can go in different parts, can be as small as this, or it could be as big as this one. You see the difference? So that is another this one is another type of DC of H-bridge. and if you compare it, it's way different in sizes. And the difference in sizes, of course, will vary. Depends on the current that it's able to draw, and that information is important because the size of the motor would depend on the size, the size of the H-grid would depend on the size of the motor that we are using. And so, similar circuit is present in our servo motor. Inside the servo motor is it also has an H-bridge, and later on we'll discuss about
one
the
of the most
operation
commonly
of this
used
servo
motors
motor.
in robotics, which is the servo motor. And I like the explanation here in the website howtomechanics.com about servo motors and how do they work. So we'll just briefly talk about just a quick introduction, just to give an idea how this guided motor works. We'll not talk too much into details about how it really works, because that would be advanced. But just to give you an idea, if you open a servo motor, what you will see is this. So you will have the gearbox, which has a lot of gears on it, and then right below the gearbox is a potentiometer. Potentiometer is a type of variable resistor, wherein its resistance is varying, depends on the position. And so that goes to show that when the knob of your servo motor rotates, then that means the resistance on this potentiometer is also changing. And this board, your circuit board here, which is the controller circuit, is getting that information, and that's how the servo motor works: the position or the degree of your servo motor. And then on this side, what you see here is basically a DC motor. That's why I told you that information that we get from learning about how a DC motor works can be useful as well with the servo motors, because underneath or inside the servo motor is just an ordinary DC motor. And we also have here on the controller circuit, what I told you about is the H-bridge, which controls the direction, whether clockwise or counterclockwise, of this DC motor. Alright? Now, here's how it works. So the servo motor is working on the variation of degrees. So that degrees is being varied by sending a PWM pulse, or the pulse width modulation. So if you send a 20 millisecond pulse, that will provide a 0 degree, and the lever of our servo motor will be on this 0 degrees. But if you put a 1 millisecond pulse, then it would provide a 90 degrees angle on the servo motor lever. And if you would like to produce a 180 degrees, then what you will have to do is send a pulse of 2 milliseconds, and that's how you make those degree changes. And if you're interested to know what are the basic applications of robotics wherein these hobby-grade servo motors are used, here they are. These robotic arm gripper, so it would have at least 1, 2, 3, 4, around 5 or sometimes 6 servo motor in one gripper or robotic arm. And then this is another one, which is a humanoid robot, which has a lot of servo motors on it. Each legs will have a lot of servo motors, as well as its arms will have so many servo motors as well. And this is also another example of the hexapad, so-called hexapad robot, which has 6 legs. Looks like a spider, but a spider will have 8 legs, but this one only have 6 legs. But you can make one that looks like a spider with 8 legs, but this one, it works basically just like how a spider works. So these are just some of the applications of the hybrid grade servo motor. Now let's see how we can program our servo motor using Arduino. So once again, let's open our Arduino. As you can see on our screen, and in my homemade robot, it has a servo motor underneath, wherein this ultrasonic sensor is connected, and to my this Arduino mini controller, this servo motor is connected to pin number, digital pin number 11. So let's do that. Since this is not a K-12 robot, we will not use the K-12 robot blocks, but instead we'll go to generic hardware and we'll get a servo motor. Let's put it on the setup, and let's change the digital pin number to pin number 11, and let's start on 0 degree. Now I'll show you what is the 0 degree. If you remember here, 0 degree is on this direction. So let's see how it looks like on our robot. So if I upload that, that's uploading. So that is the 0 degree on our robot. Now what we would like to do is move it on 90 degrees. So I'll show you how it looks on the 90 degrees. There, I just changed the angle to 90, then I click upload. And it should go to 90 degrees. There, that's the 90 degrees. And this is, if you want to change that to 180 degrees, just change the value to 180 and then hit upload again. And quickly you will see it will go to 180 degrees. Now what I would like to do is bring it back to 0, and then what we'd like to do is continuously move the servo motor as if we are moving it from 0 to 30 degrees to 90 degrees, 120 and 180 degrees, and then go back. So let's do that. We will clone this one. We'll put it inside the loop block, and then same pin number 11, but here we will start first with 0 degrees, and then I would like to put some delay. Yeah, 1 second delay is enough. And then let's clone these two blocks, and from 0 let's start with 30 degrees. Okay, then there's another delay there. So from 0 degrees it will now move to 30 degrees. So let's clone this one once again, and from 30 degrees we will go 90 degrees. Alright, as you can imagine, from here it will go this way and then 90. So from 90 degrees, let's clone this one once again, and then let's put 120 degrees, and then from 120 let's put the 120 degrees. Okay, so basically what will happen is that from 0 degrees it will go to 30, 90 degrees, 120, 180, and then it will go back to 0 degrees. Let's see how it works. Let's upload that to our Arduino. It's now uploading to our robot. 30, 90, 120, 180, 0, 30, 90, 120, and that's 180. Okay, that's cool, right? What's good about servo motors is that you can control the angle of where you want it to go. That's why it's very useful for RC robots and heavy robots. Now, I'd like to change a bit about this program because, as you can see, from 180 it goes back directly to 0. What we would like to do is from 180 it will go back to 120, 90, and so on. So let's do that. Let's clone this one. 180 will change this to 120, and then let's clone this one. From 120 let's make a 90 degrees, and then from 90 degrees let's make 30, and then eventually it will go back to 0 because this is a book block. Then let's see how it works. Then upload it to Arduino. There. So okay, from 0, 30, 90, 120, 180, 120, 90, 30, 0. Okay, so basically that's how it works. So there you have it. That's how we program our servo motor using Arduino block. You see, it's very easy. There's already a generic hardware block that is available for this servo motor. All you need to do is change the pin. Change the pin number where you would like to, where your servo motor is connected, and then just input the degrees, the angle value, so that it will go on what specific angle you would like it to go. Another commonly used motor in robotics that we'll talk about is none other than this stepper motor. And again, the explanation from how to mechatronics.com about how a stepper motor works is really good. So inside this motor, you see is this. So that's why, as you can see here, there are 4 pins, and each of those A prime and B prime are actually coils that you would need to insert power into, so that this rotator, which is basically a south and north pole magnet, will be able to rotate. And there's a lot of ways on how to drive a stepper motor. So this is one way, by single coil excitation. There's another technique which is full step drive. Another is half step drive, and the very common is the micro stepping. But we'll not talk about how to do it in details. What I would like you to know is that where they are used, where stepper motors are used, and they are commonly used in 3D printers. A 3D printer like this would have a minimum of 4 stepper motors. You see this one? So that is this stepper motor. So why minimum of 4 stepper motors? Well, because this bed of the 3D printer is moving. It's moving in X and Y axis. So it's going sideways from left to right, and it's going forward, backward, and forward, so that the print will be made. And then at the same time, while the X and Y axis is moving, the Z axis is also moving, as you can see while it was printing this object. So that's already 3, right? X, Y, and then Z. And then another stepper motor is used to feed the filament. This one, the filament will be fed through the heating element. That's why you need a minimum of 4 stepper motors. But for some, they use even more stepper motors because there are so many designs of 3D printers available now. And with 3D printers, you can do a lot. It's like this gear printing, and yeah, what you can do with 3D printer is limitless. Another commonly application of stepper motors is in industrial robots. So compared with servo motor, stepper motor is more precise. It's also used in our printers because unlike with servo motors where you're able to vary the angle or the degree of its rotation, with stepper motor you're actually able to count each step, and usually there are the most commonly used stepper motors. In one complete rotation there are 200 steps. So can you imagine that? How can you control the stepper motor with 200 steps? So that means you would really be able to make a very accurate rotation or placement of your stepper motor. That's why it's very useful for printers and for industrial robots because of its precision.
That's it for tonight, mga ka-tribe. Next week, we will go back to our K-12 robot and we will combine all the things that we've learned about this robot on how we can combine the motors, the sensors, and a lot more. And then lastly, we'll also talk about the last part of our robot, which is the speaker, and we will be able to make different sounds using our K-12 robot. Before we end, we would like to say thank you, mga ka-tribe, for supporting our advocacy to help people during this pandemic. By sharing information, technologies, and ideas that people could learn that they can use personally, perhaps to earn, to save, or simply just to ease the boredom during this pandemic while we are homebounded. So we encourage you to please share our videos, all the videos of TryPH Media, not just the videos of Try Robotics, so that you too can be helping us in sharing our advocacy. See you next week, mga ka-Try.